we will start with the first thing. That is Dr. Prithvi Chandrakanth, smartphone ophthalmologist, innovator. He doesn't need any further introduction because he is there in every conference winning so many awards. He is going to talk to us about eye examination in your fingertips. Over to you, Prithvi.
Thank you, Dr. John, for the introduction. And I'm Dr. Prithvi. I'll be taking over from here, smartphone ophthalmology. First, I'll be going to the anti-segment imaging devices. So, as we all know, slit lamp cameras are very expensive. It comes around 1 to 2 lakhs, and it is not very easy. You need to on it, you need a CPU, all those things. What if we had something much easier? So that is what is slit lamp freehand examination. So here we have Dr. John explaining to us how he uses a smartphone with freehand examination. So you can even take an image of this QR code and it will take you right to the YouTube link. So over here you can see you need to keep the phone a little away from the eyepiece, and you need to get a proper round. So you need at least of 1 finger distance between the eyepiece and the smartphone. Only then can you actually take the image. But it is very difficult because it keeps shaking. Your hand keeps shaking and it becomes difficult. So that's why we have another a product, that is a adapter. So this adapter can be used, and we can also buy it in Amazon for an amount of around 600 rupees. So this is also another way we can do this. So you can attach a smartphone to that adapter, and then the adapter can go on the eyepiece of the slit lamp. So you need to keep the phone camera centrally, and then so it can be adjusted also. So once you keep it in the center, and you can so the distance between the eyepiece you can adjust if you have a adjustable eyepiece. Otherwise you need to place it at least 1 finger gap or maybe 1 centimeter gap between the eyepiece and the smartphone. So that's when you get the proper round of the slit lamp image. And it is very easy, it's not very difficult. The only problem is you need to keep removing it now and then. Even fundus photo you can take with the 90D. So what if you don't have a slit lamp? So that is where our new this innovation comes. That is anti-segment photography with intraocular lens. This also you can take a photo of the QR code. So over here what we do is we are using a chart paper. So most likely better to take a black chart paper. So it is a 10 centimeter to 1.5 centimeter long chart paper which you can cut out, or you can even use your ID, KSOS ID to do this. So, and then you add a double-sided tape inside this thing. So you need to fold it and put a double-sided tape. Before that you can mark the area where the IOL, that's the intraocular lens, will be put. So this is the area. So between that we put this is a double-sided tape. So you have a sticky surface in both the sides which is put inside the chart paper. And then using a paper puncher, you just have to punch once on top of this chart paper. So once you've done that, you get a nice round cutout, and now inside this you are going to place a intraocular lens. So intraocular lens you can put whichever 15, 20, 25 to use it for anti-segment. If you put a 15 diopter lens, you can get a full corneal image. If you want a more focused or more enlarged one, you can put a 20 or 25 diopter IOL. So once that is done, it's sandwiched inside, and then you have to put this on the smartphone. So you need to find out which is your primary camera lens, and then you put this into your smartphone. So it makes it into a macro photography device. So it will be clear. You can, and this can be used in any phones, like with cameras in the center or at the side. So how to use it? Once you put that, you take a video mode on the flashlight and go near to the eyes, and you can start taking images. As you can see over here, you can start recording the images and you get the whole image from the recording. And you can even zoom your optical zoom in your smartphone, so that will give you more enlarged images. So these are few images taken in the smartphone, with ASPE and without slit lamp. So iris mask, giant papillae, neovascular glaucoma, corneal nerves, keratoplasty sutures, blue dot cataract with PSC, occlusio pupillae, pupillary membrane, and hyperpia. So these are all taken without slit lamp. So it is very easy. You can always keep it in your phone, in your pocket, and you can always take it. And recently we have even made into a 3D printable tool. So that can be used by just like a clip-on. So this is a video showing phacodonosis and iridodonosis, which clearly you can take it from this device and without a slit lamp. So as I said, ASPE, you can use anti-segment imaging with 15, 20 or 25. But what about other IOLs? So we started exploring more and we found that if you took any IOL with 6, 8 or 10 diopters, you can even use it for gonioscopy. So we are replacing the slit lamp over here, not the gonio lens. So with the gonio lens, you take your smartphone, keep it near to the rim, so you can take images of the gonio angles of the anterior segment also. Over here you can see ostium opening, you can see a PACS, PXF glaucoma and angle recession due to trauma. So all these are images which are taken without a slit lamp, only with the 6, 8 or 10 diopter IOLs and with a gonio lens. So this can be taken by sitting position, standing or even lying down position. Next is the IOL scope and slim. So basically we all know that microorganism we are not able to see the smartphone. So we thought why not use intraocular lens. So we used 4 30 diopter lenses over here. So we explored more with intraocular lenses and we used 4 30 diopter IOLs and we stuck with the liquid adhesives, one above the other. So it gives collectively around a 120 diopter power. So carefully place it one upon the other and then use this exactly like how we use it as a ASPE device in our smartphone. So once you've done that, it actually magnifies your phone and converts it into a microscope. So now what you need to do is, you need a slide and you need a illumination from behind the slide which will help you take the images. So this way you have attached it to the phone and then you need a source of illumination from behind the slide. So here is a torch onto which a slide is placed and then you can start taking images in the video mode. You don't really have to on the flashlight. So once you've done that, you can start taking images of fungus. Over here you can see a rhizopus slide which has been taken with the staining. Here is a KOH mount of fungal hyphae. So these are all images which were taken. This is a larvae of a sheep bot fly. This is a caterpillar hair which has been taken. So these can all be done in your OPD setup itself. You don't really have to leave your room. So you can just attach this and you can start taking images of all these things. So these are all prefixed slides which were taken. So once that was done, we thought why not use it more, explore more. So we took it to the operating theater where we went to take orbital mucormycosis case where ENT surgeon has been debriding the tissue and giving it at that same moment. And then we started taking images and we could actually find out the hyphae from this tissue. So it could actually help the ENT surgeon fix the amount of tissue which needed to be removed. So, and then we even took this and we took it and compared it with the actual microscope. You can see over here this hyphae from IOL scope and this is the hyphae which was taken in the laboratory microscope. So then we thought why not make it uses for our own slit lamp in our own slit lamp. So how can we incorporate it? So basically we see a lot of cases, corneal ulcer cases in our OPD. We need to take it, we make the slide and then we send it to the laboratory. So it sometimes takes time and all those things. So we need a laboratory setup also in our hospital. So what if we have, so over here what we did is we made the IOL scope place in the slit lamp itself. So now we have the adapter which we bought it from 600 rupees in Amazon and the torch and the IOL scope is readily available. So we fix this IOL scope to the slit lamp. So a small adjustment what you have to do is you have to remove the illumination part and then fix this adapter over there and refix the illumination part to the pivot joint of the slit lamp. You can even put it on top. If there is a place on top here, you can even put it over there and then fix it to the slit lamp. So once this is done, the adapter is then fixed with the phone attached to the IOL scope. So when that is done, what happens over here? So previously IOL scope, you need to have the free hand, so it moves. So over here you don't have to worry about the movement. It is fixed on the slit lamp. It gives you much more stabilized control over this thing. And once you put the slide, you can start taking images of the corneal ulcer, KOH mount, whatever is required at the same bedside. So here is a sample of how it's been done. So corneal ulcer been taken, scraped off, and then you put it on the slide with KOH and then put it right there and start taking images. So you can actually, it's like a more of a bedside thing. So over here we can see how we are diagnosing the fungal hyphae in KOH. And these can be done in various slit lamps, even the Hack Street model. So this was about the IOL scope and SLIM. So we have also used this for diagnosing of Demodex and a sheep bot fly, in which we take we have compared it with a microscope also. Then we come with another innovation, that is slit scope. So basically the need arises when we went to camp. So all of us, we know we go to camps, we have only our torchlight. There is no slit lamp. Sometimes it's very, very difficult to get the slit lamp and all the fundus cameras to the area because it might get damaged and then it costs a lot. So what the problem statement here was, what if we could make an instrument which would replicate the slit lamp and hence be used in community outreach program. So the solution had three main things: magnification, slit lamp illumination, and image device. And we already saw that the magnification and imaging device was taken with the